Number one proton in the nucleus stamp. One electron outside, first shell, first camp. Room temperature, it is a gas unseen. It pairs up as H2, two atoms, one team. Lightest element, so it rises and spreads. Hard to keep it still, it slips where it's led. On Earth, it rarely stays free for long. It locks in the compounds, that is where it belongs. Water holds it tight, H2O in the mix. Carbon-based molecules use it chain after chain. It sticks on the table, it's odd, not one clean family. Often placed near alkali metals, but it acts differently. One valence electron, bonding comes easy. Share it in covalent pairs, build structure steady. In water it can split, H plus can appear. Same symbol, new role, context makes it clear. Hydrogen, H number one first key. One proton sets the IDUC. H2 in the mix, but it bonds on site. Small atom, big role, from labs to starlight. Hydrogen, H number one first key. One proton sets the IDUC. H2 in the mix, but it bonds on site. Small atom, big role, from labs to starlight. Low density, so it lifts and drifts out fast. High diffusion, small molecules slip past. Hard to contain, finds leaks and seams. Storage needs seals, not hope and dreams. Mix it with oxygen, add heat or spark. It burns quick, real hazard, not a remark. To make it a liquid, cool it down deep. Around 20 Kelvin cold, you cannot keep cryogenic tanks, insulation control. Boil off happens when heat creeps close. Chemistry-wise, it bonds in a simple way. Share electrons with CON, build DNA in solution. H plus shifts what acids mean. That's why pH matters, attracts that same. Sometimes it's H minus in metal hydrides, rare but real. Same element, different charge, different deal. Hydrogen, H number one first key. One proton sets the IDUC. H2 in the mix, but it bonds on site. Small atom, big role, from labs to starlight. Hydrogen. You meet it in water, every sip, every cell, and sugars and fats too, carbon chemistry as well. Industry uses hydrogen to refine fuels, cutting down sulfur, practical rules. Big one ammonia for fertilizer supply. Haber-Bosch scaled it up, changed farming worldwide. Hydrogenation shifts, double bonds, and some reactions used in chemistry lines. Control transformations, fuel cells combine H2 and O2. Electricity flows, water comes out. That part is clear, everyone knows, but clean depends on how hydrogen is made. Source matters, methods decide what's paid. Rockets burn liquid hydrogen with liquid oxygen. High thrust, high performance, tight handling, because leaks cannot be trusted. Powerful tool, but storage stays hard. That is hydrogen in practice, engineering on guard. Hydrogen, H number one first key. One proton sets the IDUC. H2 in the mix, but it bonds on site. Small atom, big role, from labs to starlight. Hydrogen. People made hydrogen gas long before it had a name, but chemistry needed a frame to explain the same. In the 1700s, metals plus acid released it, a light and flammable layer. Early notes described it, often credited to Henry Cavendish. Careful and exact, he studied the gas, its mass, and how it reacted. Later Lavoisier helped set the meaning in place. Burn hydrogen and oxygen, water forms, that's the trace that link would shape the elements, and reactions would define. And the word hydrogen means water form, abides roots and language from there. The simplest atom became a reference point for bonding ideas, sounds, and water. And what one proton appoints, modern physics push further stars as fusion engines. Hydrogen turns to helium, energy released in steady rhythm. So the story runs from lab glass to cosmic scale. One small atom, big consequences without the fairy tale. Hydrogen, H number one first key. One proton sets the IDUC. H2 in the mix, but it bonds on site. Small atom, big role, from labs to starlight. Hydrogen, H number one first key. One proton sets the IDUC. H2 in the mix, but it bonds on site. Small atom, big role, from labs to starlight.